some kind of delay going on here. You've totally changed Hangouts again, so welcome to the new style. Well, hey everyone. My name is Fraser Cain, and I'm the publisher of Universe Today, and this is your weekly Space Hangout. Yeah, for Friday, December 13th, 2003.
Dun, dun, dun.
So joining me this week, we've got the core crew, I think. We've got Amy Shira Teitel.
Hello.
From Canada. In Canada.
In Canada. Go team.
Welcome home.
Thank you.
Got David Dickinson in Florida, wishing he was in Canada. No, wait, it's the opposite.
only warm spot in North America right now.
Oh. Jason Major.
In Rhode Island.
In Rhode Island, a sort of a horrible cross between Florida and Canada.
We're just northern Florida, really?
Right.
I'm so confused right now.
And confused Nicole Gugliucci.
It happens. Most of the time.
Most of the time. Cool. So we've got a bunch of stuff we're going to talk about today, I think. We're going to talk about the Geminid meteors, which is why David Dickinson looks so tired. We're going to talk about the forthcoming Chinese landing on the moon. Apparently a rocket, not an entire country or people. So we're going to talk about crazy jets on Europa. Just another reason why we're not allowed to land on Europa.
J-E-T-S! Europa!
Once a jet, always a jet.
That's a good one.
Reasons why a star might not be a star. And then Lakes on Titan. It's just a liquidy episode. An exoplanet with the biggest orbit, and a interesting molecular cloud, M51. So let's start with the Geminids, because we love meteors. So David, why are you so tired?
Because I was out looking for the last few mornings. I was out on vigil for the Geminid meteors, which is one of the most dependable meteor showers of the year. And currently, the Geminids have been getting more and more active every year too. So it's currently one of the best annual showers, even better than the Perseids. But I think the Geminids, due to the fact they happen in December, which is the middle of Northern Hemisphere winter, kind of have a PR problem as compared to the Perseids. But the Geminids, their rate right now is approaching up toward zenith hourly rate is in the past few years has been approaching over 120 per hour, which is pretty good. So you could expect to see 1 to 2 per hour depending on how dark your sky is. One problem we have this year is the pesky moon. The moon is at waxing gibbous right now, and it's going toward full next week. So we only got a slice of very early morning where there's no moon, and the sun hasn't risen yet, and there's no dawn twilight right now. So, and that's dwindling. So that's why I've been trying to get out the last few mornings. I've seen a few. I was looking on the International Meteor Observers Association's website. Their last real-time data came from 12:30 UT, which is 7:30 our time, Eastern time here today, and their zenith hourly rate was showing 63 per hour. But that was plus or minus 22, so that tells me that's a very low data set of observers. That's kind of a wide distribution right there. But this is an interesting shower to watch for, and this shower also is interesting in that it comes from the controversial rock comet 32 Phaethon, which is which has the behavior sometimes of an asteroid, sometimes of a comet. It's a comet that gets very close into the sun, closer in than Mercury on perihelion, so it's periodically, what they think is happening is it's getting material baked off it, like ice and things are sublimating off it. They also think this might actually be a dead nucleus to a comet that was once active, got captured in the inner solar system. There's a lot of theories, and they didn't know the source of the Geminids until it was astronomer Fred Whipple in the mid-20th century that calculated, based on the orbit of 32 Phaethon, where the Geminids were probably coming from, what the source body was.
So when's the peak? What's the best?
The peak is coming at, I always think in universal time, so for Eastern observers, you'll just have to minus 5 hours right now that we're on standard time, is 2 o'clock in the morning universal time tomorrow, which favors the Atlantic because we're going to be turned forward. We won't be here on the U.S. East Coast, but on the other side of the Atlantic, it's going to favor UK, Europe, and then. But the peak really, this shower is a very broad 24-hour peak. It's not like the quaternids that come next month, which are powerful, but some meteor showers only have a peak that lasts an hour or two. This one usually lasts over 24 hours. I was at a dark sky site in North Carolina, in western North Carolina last year, and I saw quite a few. The shower was one of the better displays of the Geminids or any meteor shower I had seen for some time.
Now, is
And
this
I
a
noticed
firefall shower, Dave?
the average ratio between it's not exceptionally not compared to the Perseids or any other. There are some showers like the Taurids that have a high ratio of fireballs as opposed to lower magnitude meteors. This one's it's about an even mix. This shower here, so I'll be trying to take images tomorrow and I'll be out again if it's clear.
Well, I'll admit I'm a total fair weather meteor guy, especially so I love the Perseids. You know, the Leonids and the Geminids really kind of test my patience. I'll go out for a little while and look up, and then I'll get cold and go, I'll wait for summer.
Well, it's tough when you're imaging, too, because cold weather will kill batteries in a hurry, and if you're doing time exposures on cameras, that will also drain your batteries in a hurry. So
I just got a new camera, by the way.
Yeah.
I got
cool.
a 5D Mark II.
Oh, very cool.
Yeah, so I'm really excited. We're going to use it for shooting video, but I will also be using it for time lapses and things like that. So, yeah.
I usually carry an extra set of batteries in my pocket just to keep them warm. A lot of people will use external battery packs, or if you're near an AC source, you could have an AC power pack. That'd be another way to. But catching meteors is just a matter of shooting at a very wide exposure, a wide field of view, and it's something you can't really plan for. They can appear anywhere in the sky. They're going to radiate from the constellation Gemini. That's why they're called Geminids. But you just aim with the widest field of view you can and just do time exposures. With the moon up, too, you're going to probably have to keep the exposures pretty short because they'll wash out otherwise, unfortunately.
There's a little bit of housekeeping I should do before we kind of move on to the next story. One is I forgot to turn on the Q&A app, so you can't ask your questions to us within the Q&A app, and I apologize in advance because I'm a big fan of it. Except for all the ways that it's complicated and doesn't work. But other than that, it's awesome. So you're going to have to, if you have any questions for us, you're going to have to post. And now there's more places to post because they've changed the way Hangouts work. So, Nicole, you're going to be watching the Weekly Space Hangout, the event page, if there's any comments there. The YouTube, maybe. Watch Twitter. Watch the Sky. And I will watch the Google Plus on my stream as well, because there's more comments there you didn't even realize.
Gotcha.
So
I don't have Twitter open. Don't count on Twitter.
Don't count on Twitter. Okay. And so the second thing is, now I know Jason showed off this. So here is the Year in Space calendar from our good friend Steve Carady. Anyway, so we're giving away 5 more of these. We already gave away 5. We're going to give away 5 more on Universe Today. There's a giveaway on Universe Today. All you have to do is just put in your email address and click join giveaway, and then your name's in the hat, and we'll pick some names in another couple of days. I think we wrap up on the 16th. So just come to Universe Today.
Even if you don't win one, it's definitely worth buying. I mean, I think they're selling for about $13, and this calendar has more space info than you could possibly hope for. Every day has space facts on it, and I, as someone who tweets a lot about space, I use it for just ideas as far as like space history and what's happened. For example, 42 years ago today was the final day of the Apollo 17 mission. That's all on there. So it gives you some good ideas of what's happened.
And I know it sounds like I'm a paid shill, but we're actually not. So we every year he releases these calendars, and I really like them, and I want to support what he's doing, and so we give a bunch away and help him promote it, and no, except for the calendar coming to my house, no money crosses any palm. So the other
like
thing,
a good holiday gift.
the other thing, which I think is another awesome holiday gift, and we're kind of running out of time, and it might be even too late, is the Kerbal Space Program is on sale for 40% off today. So through Steam. So if you have any interest, this is this video game where you get to experience spaceflight with these tiny little Kerbals. It's a solar system physics simulator with a bunch of rocket parts, and you can put them together any way you want and try to just do all kinds of missions
and blow things up.
And blow things up.
And check that out.
Yeah, and kill Kerbals en masse. I apologize to the ones that are they're like plant-based, so they can stay in orbit literally forever. And many of mine still are out there orbiting. I can't say when I will work up how I'm going to rescue them. But yeah, I mean, it's amazing to think about. Like, how do you do a lander, and how do you get the mission back off the moon and back to the home planet, and it's a great game. I highly recommend it. A really active community. It's still in alpha, but it's a very mature program. So anyway, and I think it's on 40%. It's like $16 today. I'm not sure how much longer. So, and then the next thing is, Nicole, you've got a app you wanted to talk about briefly.
I do. So CosmoQuest has put out a new app for Android users. Sorry, iOS, we're getting to it. We actually had to wait for money to come in so that our developer could get a license. So Joe Moore, one of the developers for CosmoQuest, has finished his master's project, and he passed his presentation this week. Congratulations, Joe. And you can now enjoy the fruits of his master's project as he heads off to graduation tomorrow. The app is called Earth or Not Earth. It's available on the Google Play Store. I'll put a link at the event page and on the YouTube. It is a game that gives you aerial photos. I don't know how well you guys can see this, but it gives you aerial photos of some world in the solar system, and you have to decide, is it Earth or is it not Earth? If you want something more challenging, you can go up to the next one, where you actually have to define what planet or moon or thing it is that you're looking at. There's a matching game. There are vocabulary cards you can learn. You can brag about your scores on Facebook and compete with your friends. This is $1.99 on the Android Google Play Store. Check it out. It is really fun. I will not challenge. I started challenging people to beat my high score, but I actually found most of the images for the app, so that's probably not fair.
Right.
But it is, even after doing that, it is super fun. So check out Earth or Not Earth on the Google Play Store.
That's cool.
And come play with us. And
then the last thing is, you know, I do this Phases of the Moon app. So we're part of a promotion with this group called Free App of the Day. Many of you probably even have this. So on Monday, our Phases of the Moon is going to be free on iOS.
Very cool.
Yeah. So this is the one. So if you have iOS, so this is the Android version, right? But if you have,
I like how you included the labeled map too, where you can actually see the.
it has a permanent place on my Android desktop.
Yeah. So that's the Android
phone.
one, and we actually have a free version of the Android one, and we removed all the ads yesterday, I think, and we had 150,000 downloads of it yesterday. So
Sure.
I think it's going to be a lot bigger even on Monday because their iOS version is even bigger. So on Monday, just remember, download a free copy of Phases of the Moon if you have an iPhone or an iPod or an iPad. So free. Merry Christmas.
Very cool.
Okay, so let's move on to some additional conversations.
Thanks, Anna Fraser.
No problem. Okay, well, let's talk about these jets on Europa.
Jets on Europa. Yeah, this is super cool news. I mean, this is probably one of the big news stories of the year in my not so professional personal opinion. So we all know that Enceladus, Saturn's moons, has jets of ice and dust shooting from its south pole. And we've known this since Cassini discovered the jets in 2005. Well, as it turns out, Jupiter's moon, Europa, that's the one from 2010, attempt no landings there, also has jets. Now, we don't know exactly if they're jets per se, just like Enceladus's. This is still kind of a preliminary announcement, but everything's pointing to the fact that Europa, at some point during its orbit around Jupiter, is shooting some of its liquid out into space. Now, whether or not the liquid is water vapor, it was detected with Hubble. So the signatures are of hydrogen and oxygen ions that seem to be emanating from the south pole of Europa. Now, again, whether or not this water vapor is actually coming up from inside Europa, or whether it's coming from melting ice, that surface ice, not quite sure yet. So there's still some observations that need to be made to kind of tell where it's all coming from. But what's happening is as Europa orbits Jupiter, it goes around Jupiter once every 3.5 days. It has an elliptical orbit, which means that at some point it's closer to Jupiter than at other points, and when it's closer, it gets gravitationally squeezed by Jupiter's gravity. Tidal stresses kind of squish it, and there's no jets at that point. And when it's further out in its orbit, it kind of Jupiter's gravity releases it a little bit, the cracks in the ice potentially open up and spray some of that water vapor out into space from Europa's South Pole. The takeaway from this is if we want to sample the potential underground ocean or subsurface ocean that's on Europa, we don't necessarily have to land and drill and send a robotic, a robotic probe down under the ice, although that's a good idea. We don't have to do that. All we have to do is fly a spacecraft through these plumes, Cassini-like, to get a taste of what's actually happening inside Europa. So that's the big news, and it's kind of ironic that this news should be coming out on the heels of an announcement by NASA that they're not going to be awarding any new planetary science grants in 2014. So it's kind of like your move now, NASA. The research came out of the Southwest Research Institute, obviously planetary science. So now what are you going to do? Should we go investigate? Probably should.
Yeah, this is gigantic news. I think this is the story of the year, and here we are on the last couple of days of December, and we actually just completed a bunch of interviews with a bunch of people. We talked to Mike Brown, talked to Emily Lakdawalla. In fact, we just released a video with Emily Lakdawalla, and this is exactly what she said. She said, "Forget Mars. We want to find life on Europa and Enceladus. That's where we think we're going to find it, because you've got water right now with you've got water, you've got access, you've got rock, you've got places where complex molecules can be forming with chemical and energy sources."
What's handy about Europa versus Enceladus is, it's basically about 300 million miles. So it's just a little bit of a closer proximity to actually get a spacecraft over around Jupiter. Now, yes, Juno is going to Jupiter, and it's going to get there in, I believe, 2016. Unfortunately, Juno's not necessarily made to investigate Europa. Yeah. It's a spinning spacecraft. It's going to take a polar orbit around Jupiter. It's not really going to be doing Europa studies. So can they tweak the mission to kind of take a look over there? Yeah, they're going to see what they can do with that. But it's not a dedicated mission. So that's what really needs to kind of get dusted off. Maybe the Europa Clipper mission that was.
I think we did a Stardust. Like, you remember the Stardust mission that flew through the comet tail and had the aerogel and grabbed all those particles? Yeah. Well, imagine same thing, right? You create a version of Stardust. Just take the same spacecraft, right? Fire it off to Jupiter. Have it just keep flying through Europa's plume, capturing molecules, and then have it return to Earth, and then they can examine them. I think this is great because people have always really felt excited about the potential for there being life underneath the ice on Europa, but it's just like, but how are you going to grind through 10 kilometers worth of ice to get down? It's some kind of submarine. Do you send a nuclear reactor that melts down? No, Europa's firing the water into space for you to fly through. This is amazing.
Yeah, if Europa's giving us the stuff, shouldn't we go get it?
Should we go get it? It's right there.
It's right there.
This is starting to seem stupider and stupider that we're not doing this.
Now, again, it's not known whether or not the water vapor is originating from the subsurface ocean. So there's a little bit of a science buzzkill here. The announcement isn't. It's not the science gold standard of a 5 sigma, where basically, yes, it's 99.9999% sure that this is happening. It's a 4 sigma, so it's only 98% sure of actually existing, and it's not noise. So there's more observations. Need to be made to see what exactly this is, where it's coming from, and it just shows that there's more planetary science that has to be made here, and to stop writing checks out to it is going to be it's going to make that difficult, and this is going to be the question of, this is really the discovery probably of the year, and it's going to be the big question of next year, and who's going to be researching it.
Forget Mars. Let's go to Europa. I don't care what those aliens say. We are landing.
Jason, there was a paper going around this week, too, that some sort of panspermia or exchange of organic material may have occurred between Earth, Mars, and I think they mentioned Europa, too, for that reason about the impact.
Well, what they did mention at one point, and I mean, I think this was only last week, they were saying that Europa could have had some clays deposited on it from a massive impact at one point.
Chicxulub, like the one that wiped out the dinosaurs, is I think the one they cited, the one 65 million years ago. Yeah.
So they're looking at, well, I think there were a couple things. There was the idea that massive impacts on Earth could have sent out material to the rest of the solar system. It would have just made sense that over the course of millions of years, that some of the stuff that got blown off of Earth that already had organic molecules and chemistry developed on it could have landed other places. And then there was the information that that clays could have been dropped on Europa through possibly a cometary impact as well, and they kind of like highlighted a little spot there.
They'll land on Europa and find the hubcap that Project Plumbob blew off in the 1950s from a nuclear explosion, I bet, sitting on the surface.
Vigor.
We have a question from Hugo Burnham. Has the HST looked at Callisto for similar plumes, or have any plans to? And I'm wondering, same for Ganymede, because all three of those moons likely have some subsurface ocean. Have you heard anything about that?
I have not seen anything about Callisto or Ganymede. The observations were really centered on Europa, and the observations were all in. It wasn't invisible light, so it's again not like Enceladus where we can just look at it in the right lighting and see these jets shooting out of the ice. This was all in ultraviolet. And it was all signatures of hydrogen and oxygen ions. So invisible light, not yet. We haven't even seen anything. So it's still not quite Enceladus, but again, it might just need some more observation. Again, there's not a Cassini-like mission around Jupiter. So
anymore.
Not anymore.
Galileo, we loved you.
Yeah. All right. Well, okay. So Amy, top that. Exoplanet with the biggest orbit.
Can't really top that, but I'll do my darndest. So yeah, I liked this a lot, and not enough on the news, so I missed this. But astronomers at the University of Arizona found a planet that, by all accounts, should not actually exist. So this is an exoplanet, not a planet in our solar system. I should make that very clear. The planet is called, HD 106906b. We'll just leave it there. So it's orbiting its star. It's 11 times as massive as Jupiter, but it's not the size that's really interesting. It's the fact that it's orbiting its star 650 astronomical units away. So one astronomical unit, of course, is the distance between the Earth and the Sun, which is about 93 million miles. So this massive 11 times the size of Jupiter planet is orbiting 60,450,000,000 miles from its sun. So this doesn't make any sense according to anything that astronomers know about how planets are formed, because generally planets form right when the disk of gas and dust coalesces. The planets closer to the sun tend to get some more of the material and get denser, and the planets like Jupiter oftentimes we think they are sort of failed stars or planets that sort of coalesced in sort of the early, like with some big event in the early solar system's early life, but this one just sort of doesn't make sense. So one theory that might explain it maybe is that it's actually a failed star in its own right, more so than Jupiter, obviously being bigger, and it would have made a binary system with its star, but it just wasn't quite big enough to start burning and start become a star, so you ended up with this massive planet really far away from the star, but they ended up sort of gravitationally locked to one another. But the issue with this explanation is that it's too dense for its star to have been formed at the same time in sort of a binary system. So it's one of those exoplanets that's, again, like so many of the more recent discoveries, is just completely turning everything we think we know about how exoplanets form and how planets form on its head. It's okay. So we think we know how planets are formed, and then we find this thing, and all of a sudden we have to figure out how to explain it and then see if there are other things out there that then fall under this new explanation of how planets are made. So this is really cool. I love these stories that sort of take everything we know and tell us that we're wrong.
Well, one of the ideas, or one of the problems with the sort of planetary formation idea of these idea of these rogue planets, right? That if you have a lot of matter, a star's worth of matter, then it's going to collapse down. It's going to create stellar fusion, and you're going to get a star. And they're easy to find because they're bright. But if you have a smaller amount of matter, like a few dozen Jupiters worth of gas and dust, will that collapse down, and will that turn into a planety type thing without a star?
Yeah.
And how do you find them? Because they're not going to give off any kind of radiation. In this case, it's reflecting light from its parent star. But you can imagine.
Well, in this case, it's actually emitting. It's young enough, actually. Sorry, I sort of glossed over this. It's actually young enough. Looking up it's 13 million years old, whereas the Earth is, what? How old is the Earth?
4.5 billion years
right?
old.
Yeah.
So it's young. It's actually still emitting infrared light or heat rather, in the form of infrared light. So it's still kind of glowing, but not bright glowing.
Yeah, you touched on it, Amy, too. Is that it is just below the level for deuterium fusion for a brown dwarf. I think it's about 13 to 15 Jupiter masses usually. So it's just shy of being substellar.
Yeah, people always wonder, like, what would it take to ignite Jupiter and turn it into a star? And all it would take is crashing 13 more Jupiters into it.
A lot of monoliths.
Easy.
Yeah.
I like that we can talk about something being 14 times the mass of Jupiter as a relatively small amount of material.
It's a little guy. Yeah.
Yeah.
Okay, cool. Let's see. Let's move
Well,
on.
considering that the sun, our sun takes up 99% of the mass in the whole solar system, and everything else, including Jupiter, is in that remaining some odd percent. That mass is. Then it becomes a little easier to envision that mass is out there, and you could just kind of chuck it into stuff.
Yeah.
You guys are funny.
Why?
Dr. Nicole Gugliucci.
Why?
Right,
Because
we
we're
have the
not
doctor among us.
Nicole? Oh, I'm sorry.
Just because everything, I build things and it's hard, but I don't build planets, so.
In my imagination, all this stuff is easy.
I know. That's why I love you.
It drives Pamela crazy, too. I'm like, well, we could just do this. Do you know how hard that is to do this and that? That's crazy. Not in my mind. It's easy. I just did it.
You should be a theorist, Fraser.
Piece of cake. Well, do you want to see me imagine something else right now? Done. Okay. Well, let's move on. So, Nicole, do you want to talk about your molecular cloud?
Sure. Although I thought that was a good segue for Jason's story, personally.
What, brown dwarfs out of the brown dwarf story? Who would have picked that up?
Yeah, fine. Go ahead. Well, I didn't want to leave Nicole hanging because we're about to concentrate the laser beam of stories on Dave and Jason.
I'll make this quick.
I'm chatting with our commenters. It's fine.
I'll make this quick for two reasons. One, because I don't want to leave Nicole hanging, and for two, I don't know all that much about it to go really deep into the science behind it. But so basically, if we're talking about brown dwarfs, we're talking about stars that quote-unquote have failed. Now, I hate that term because it implies that there's a test for stars, and I like to be a little more egalitarian regarding that. So it's just whether or not this object has gained enough mass to start burning, or fusing, I should say, fusing hydrogen at its core. Brown dwarfs are much bigger than Jupiter. I hate saying this too. Not bigger, more massive than Jupiter, but they haven't ignited yet. So they can't be technically stars. But the trick is where is that line? Science likes to know, black and white. It's you're a brown dwarf, are you a star, are you not a star? So researchers from the university, or Georgia State University, have pretty much come down to what that boundary line is. And as it turns out, there's a temperature level that is 2100 Kelvin is the kind of the temperature at which a star is no longer a star. It's not a little star, it's not a it's not a big planet. It's a brown dwarf, and so that's our temperature line there. And it's let's see, the radius would be 8.7% of our sun. And the luminosity is tiny. I mean, the luminosity is 1/8,000th of the sun. So these objects are where that line, that dividing line between a brown dwarf and a really, really, really little star. Why is that important? That's important because of how these objects cool off, and potentially how they may have exoplanets around them, and where to look for life elsewhere in the galaxy. Brown dwarfs cool off in the terms of millions of years, whereas if it's actually a star and it's fusing, then it's going to cool off much, much, much slower. If there are exoplanets around these objects, obviously exoplanets that are orbiting a star would have a lot more time for life to develop, or organics to develop, or turn into whatever, whereas anything orbiting a brown dwarf, if there is something there, I'm not sure if you would call those exoplanets, if they'd be kind of more like moons. That's a semantic debate for another time, but the heat's just not there to make them habitable. The habitable zone would be much, much smaller and wouldn't last nearly as long. So that's our dividing line. This is 2100 K is basically the end point for a star. Any cooler than that, and you have a brown dwarf.
Is that based on what the surface temperature is if there's fusion in the core? Is that like the fusion on, fusion off barrier? Is that where they came up with that?
Well, let's see. What are we looking at here? It's decreasing temperatures. They're looking at the light. You know what? If you want to know more, check out my article over on Universe Today.
They're doing deuterium fusion too. They're not burning.
Yeah.
They're not doing the full proton-proton chain. They're doing the very beginning of the proton-proton chain, but they can't do the full thing up to helium. So they're just doing 2 hydrogen atoms into 1 deuterium.
That's hardly fusion.
Yeah.
So is this where we find out that the sun is no longer a star?
No.
Why would you say that?
I always heard
Not a
that
planet. The sun, not a star.
The moon is hollow.
hollow.
You know, I
Exactly.
have no mouth and I must scream. All that stuff. Yeah.
Aliens.
And one of the interesting things when we're talking about brown dwarfs is how they react to mass. You could talk about adding more mass to these things, but it doesn't necessarily make them larger. As brown dwarfs and objects like that, and even things like super Jupiters in other in exosystems, at a certain point, they don't get any bigger. They actually start to get a little smaller because the mass just starts bringing them in. It's been likened to springs on a mattress. You put more stuff on it, and they just compress. So you know that's why it's tricky to say large, big, because they're not actually bigger. It's just about how much mass they have in them, and that's where you start talking about whether or not they can fuse. It's that heat, it's that gravity on the inside of them that gets to that fusion point.
Nicole, you can run no longer. Let's talk about your molecular cloud.
Well, first I want to address a question from Rich Hayward asking about Amy's story. Is it possible that it's so far out it could be a captured rogue planet? I don't know if you have any comment on that. My guess would be no, because that's really difficult to do.
Yeah, I don't know either, but thinking about it when I was writing that article, I also thought probably not, because I can't imagine where it could have been that something could have passed it to like whip it out of its out of one solar system, and then to be captured so far away from a star.
Three-body interaction.
So
That would be unusual.
Three-body interaction, it'd have to come pretty close.
Yeah.
And that
Probably
young
not.
age is going to be tricky like that. I mean, like I said, it's only 13
yeah.
million years, so
it's
not a lot of time for something like that to develop a stable orbit.
Yeah.
The Pan-STARRS survey did find a rogue planet earlier this year, about 80 light years out. They found it in that was the WISE survey, actually, in the infrared survey.
Yeah,
they
that makes
found
sense.
Yeah.
Right.
Okay, so
now I will
that's it,
talk about
Nicole.
molecular
Now,
clouds.
now can we talk about a molecular cloud?
Yes, we can talk about molecular clouds. I had this. This was actually a special request from Kakambo, some concatenation of numbers on Twitter, asking about this story. This is a map that I'm going to be showing you. This is of the molecular clouds in the Whirlpool galaxy M51, overlaid over.
Uh-oh.
Oh, we lost you.
The
Picture's
galaxy
still up.
gutter.
Yeah, the galaxy got. We see your galaxy.
She's become a
Nicole, but
galaxy.
We can no longer hear you.
It looks pretty though.
And now we're losing her entirely. There we go.
There she.
There she is.
Maybe.
This is the alternate
This
version
this
of
this
Nicole.
is how this is how she gets out of doing this story. Fine.
It's all a ruse.
You're breaking up.
Quickly, Jason, while she's returning, let's talk about this cool lake on Titan, and I'm going to try and show this video.
Well, there's a lot of
This is
lakes.
not
on-
my day.
There are a lot of lakes on Titan. They're not filled with water like we have here on Earth. They're filled with liquid methane. Because it's very cold on Titan, it's about 300 degrees below Fahrenheit. So that's the temperature where gases here are liquids there. And Cassini has done 9 years of radar research during Titan flybys, and NASA just put together a really nice video of a flyby or a flyover of Titan's northern pole. And as it turns out, almost all of Titan's lakes are in one 600 by 1100 mile region around its north pole. In fact, only 3% of the liquid on Titan's surface is outside of this region. So it's basically Titan's version of a Land O'Lakes.
I'm listening to some really lovely music right now that you can't hear.
So here's a flyby, or a flyover. It's using colorized radar data, so we're not actually looking at optical data. The radar instrument on Cassini can bounce radar off of the surface of Titan, and it can tell where smooth surfaces are, probably the lake surfaces, and where surface is, non-liquid surfaces are, because the surfaces of Titan's methane lakes are extremely, extremely smooth and radar reflective. So they show up. I shouldn't say they're radar reflective. They're not radar reflective. They show up as these big dark regions that have almost no texture to them at all. In fact, they've been likened to the paint on our cars. That's how smooth these lakes are. Now, one of the lakes, Cassini was able to shoot some radar down through to determine its depth. And I want to say, I don't have the numbers in front of me, I want to say that the depth was determined to be somewhere around 500 feet. So these lakes are a lot deeper, at least in some parts, than we even thought they were. They're not just ephemeral lakes that disappear seasonally. I mean, these things are there to stay, at least for a long term. So why they're all there in this one zone, not quite sure. It just may be the part of the tectonics of Titan's surface. Maybe there was, maybe there's divots in the surface that keep it there. So that's just going to be the ongoing study of Titan's lakes. And,
yeah, the mission. There was that mission, sailboat for Titan's lakes, right?
Titan Lake Lander. Yeah.
That'd be crazy. That'd be
Yeah,
so
that'd
great
be
to have a
awesome.
sailboat.
Awesome.
Yeah, zipping around those lakes and exploring and scooping up liquid methane samples, liquid hydrocarbon samples, and testing them for life. I think it'll be great. So
the testament here is having a mission around Saturn, or studying a system for long periods of time, going through seasonal changes. That's the key. It's not just a flyby. It's not just a landing and then the batteries run out. Cassini has been studying Saturn and its moons for 9 years now, and so it's seeing a lot of different things, and it has a chance to make real long-term observations. That's key to understanding what's happening in our solar system.
all hail Cassini. David, the Chinese are about to land on the moon.
Yes, the Chinese are landing tomorrow, or rather, one of their landers with a rover on it is landing. The Chang'e 3 probe is landing. The time I'm seeing right now is 13:10 UT, which is about subtract 5, 8:10 tomorrow morning Eastern Standard Time. The Chinese national television, CCTV, may be carrying it. What I'm hearing, it's always kind of just check and look to see if they're actually going to be broadcasting this. They don't broadcast every space event, but usually the high-profile ones, they'll do something near time, if not live time. I don't know if we're going to get images from the surface or how soon that's going to occur. It's landing in the sinus iridum region of the near side of the moon, which is just being illuminated right now on the waxing gibbous moon. So you can actually go up there tonight and see that one little dark Maria where they're landing their lander and rover tomorrow. And it's actually plutonium powered too. I thought that was interesting that they need the plutonium power source on it to survive the 2-week-long nighttime on the moon. It's partially solar powered. Oh, it's pretty good infographic there.
Yeah, so I don't know how your Chinese is. Mine's pretty.
Mine's
terrible.
pretty good.
Yeah, but look. I mean, what does it look like? It looks like Sojourner, right?
Looks a lot like Sojourner. Yeah.
Oh my God, it does!
This will be the last. This will be the first rover, the first landing on the moon, soft landing. I mean, we've impacted things over the past few years. Since 1976, the Russians were the last ones to land an automated probe back in 1976. So it's been a while.
Was that a Lunar?
I think it was. Well, I think it was their sample soil return that the Russians did an automated soil return. I'm pretty sure. And interestingly, Laddie will be watching too to see how this affects the dust environment of the moon once this lands and stirs up the dust. So it'll be interesting to watch.
That's great.
Sure
And
at the end of the weekend, we'll have pictures from the lunar surface again for the first time in over 30 years.
And I'm going to recommend, although she's not here with us today, is Emily Lochte-Wallace's coverage of this. She's been all over this.
Yeah,
I've been really great coverage of this. And so go check out the Planetary Society. Emily Lochte-Wallace coverage of this mission is just perfect. So
that's fantastic. I mean, think about it. 41 years after Apollo 17 lifted off, and you know, we're going to have another landing. Humans will have another landing on the moon.
A few weeks ago, Universe Today wrote about this, and I wrote about it on my site too. South Korea has evinced interest in sending a lander to the moon by 2022. So they actually did a press release, and they showed a small lander that they want to send up there, which they just orbited their first satellite, their first indigenous satellite, without using another carrier from their own soil last year. So they just entered the space race last year. So.
Now, don't you feel like you're on a roller coaster here where, like, NASA budget cuts, oh, SpaceX, yay! Chinese launching, you know, landing on the moon, yay!
India's going to Mars.
Yeah, India's going to Mars.
We sent Maven off, too, so we did send something off to Mars this year. So we've got a few missions heading out this year.
Now is this the whole Google Lunar X Prize event? I mean, are they you know, working this in there, or is this something entirely different?
I don't know. I don't know about that.
I'm pretty sure it's totally different.
Totally different. Okay.
Because
they'd have it. I mean, this. I mean, they're doing what the X Prize is supposedly, you know, calling for.
Except they're doing it with the might of a global superpower. Yeah, as opposed to a small team of people doing it on the cheap. So, which was the whole point of the X Prize. Okay. Well, one last story, and this is one that's sort of.
Can I try again?
Sorry, who?
Are you going to turn into a galaxy again?
All right.
No, I'm not going to screen share, but can I try again?
Yeah, no, please.
Okay, all right. I want to finish my M51 story, which I showed you, and that crashed my laptop. See, I've been kicked out of my office because we're moving, so that's why I'm on my laptop. Anyway, so they did this molecular cloud study over several years using this interferometer in the Alps. Mapping out the molecular clouds, and for the first time getting images of the molecular clouds at a certain scale. We know that really, really dense molecular clouds are what create stars, but there are also these bigger diffuse, and they discovered kind of this molecular fog. They traced it with carbon monoxide, and they used that to trace the molecular hydrogen gas. And we're able to tell from different places in the densities where star formation may or may not be happening. So they correlated it with all the optical data of this galaxy, with ultraviolet data of this galaxy, with infrared images of this galaxy to see where the molecular clouds were either forming stars or not forming stars, to really understand more about how that process works. Though we know overall how the process works in star formation, we don't know a lot of the details. We don't know how much these giant molecular cloud complexes, why only some percentage of it, so in the Milky Way it's some small percentage that actually turns into stars, why it does that. So this is a really cool study. Again, it's millimeter wave interferometry. It's the kind of, this is something that they can look at further with ALMA. The problem with ALMA is it's so popular. Everyone wants time on it. And so that's why they were able to use the Plateau de Beard instrument to look at this for many, many, many hours, over many, many, many years, to get that gorgeous map that then crashed my computer. So that is the molecular cloud story. I will share that link.
Yeah, I know it's a beautiful picture. We Instagrammed it.
You Instagrammed it. That's great.
That makes it cool.
That's
makes it
just
better.
that was yeah. I think we got 100 likes. Universe Today on Instagram.
We totally missed the drama on the ISS that's going on.
Yeah, so that was the last thing
Yes.
that was the last thing that I wanted to talk about. And David, have you been?
Yeah, I haven't seen the updates today, but I know they lost one of the coolant loops on the ISS a few days ago. I don't know if they ever got it back online. But they were talking about, last time I saw, me and Jason were talking about this on Twitter Wednesday night, as a matter of fact. They were talking about doing a contingency spacewalk to try to repair it, if they can repair it. I think right now what they're looking at to see if it's even something they can go out and repair. But I know they're moving ahead with the Antares Cygnus launch next week, so that's a good sign. But as far as I've heard right now, they're still looking at seeing what they're going to do to repair that. It's definitely not putting them, it's a redundant system, so they have their cooling still in place, and they're entering into a time of year right now where the ISS actually enters into its inclination. Its orbit is high enough that it goes into full illumination. So heating and cooling is definitely an issue this time of year, right around the solstice, because they're entering in that time where their orbit is perpendicular to the sun, so they're staying up in full illumination the entire time. And they can do things like feather the panels to kind of create artificial shadow and things like that, but they like to have both of those ammonia cooling systems up online. It's kind of putting them in a precarious situation. It could. Right now it's urgent. It's not an emergency, but it's not good.
Yeah, one of the things that people have asked me about conditions on the space station and other spacecraft. You talk about, I mean, they think that if there's a problem with the HVAC or whatever type system they have there, that getting colder would be an issue. It's actually keeping it cool because of all the stuff that they have running in there. It can get warm inside the ISS. So they want to make sure that keeps it down. So it's not so much freezing in there. It's actually overheating.
Yeah, definitely. So I haven't heard of.
According to NASA right now, and I know they're gonna say everything's okay, even if it's not quite okay. But there's not a life-threatening situation. I know when it first came out, when the news first broke yesterday, there was a lot of hand waving about that.
I haven't seen a lot of talk about it today. I think that unless they changed it and haven't said it yet, I think that they're moving ahead with the Antares mission next week is a good sign.
Mm-hmm.
That it's
the Orbital Sciences launch.
Yeah,
okay.
As far as I know, they're moving ahead with that. I haven't checked in the last few hours. Maybe they. I know Wednesday night they were talking about maybe pushing that off a bit. But that sounds to me like they're still wanting to do business as usual. And I haven't heard talk about doing a spacewalk per se, but who knows?
All right, well, we should probably wrap things up. Hopefully we'll get some more news over this coming week on what's happening with the space station, and I'm sure it'll be fine. But I like how you said that, right? Like that if NASA's going to tell you that everything's fine, even if things aren't fine, and they're telling you that it's fine. so everything's just fine. Amy Shira Teitel, where do we find out more?
Popular Science for now. Yeah, let's do that.
Fine. Popular Science.
Been working on some stuff and haven't been on the internet lately, so Popular Science is where I'm sort of regularly right now.
What kind of stuff?
Some larger format book-related stuff that I will talk about later.
All right. You tell us when you can talk about things.
Yes. Yeah.
All right. David Dickinson.
Oh, this week I was active on my own site, Astroguys with a Z, Universe Today, Listosaur, Canada.com. And I'm heading out of here to do a school star party tonight. And I'd just like to give a PSA that if you're a teacher and you're having a parent-teachers night, having a star party is a great idea to kind of ease the tension a little bit. Every time I've seen schools do this and do a parent-teachers night and do a star party, it usually turns out that people actually look forward to parent-teachers night. So
there is nothing more calming and fun than a telescope set up out front of the parent-teacher night.
As a teacher, I can tell you myself that parents and teachers generally dread parent-teachers night. and it can make it a little bit of fun.
That's awesome. Jason. Jason.
I am as always, at lightsinthedark.com. I also write for Universe Today, and I should be back on Discovery News Space come 2014. And I'm on Twitter at JP Major, so you can find all sorts of space news and stuff by following me, because I have no life and I just tell everybody all about space. Awesome friends.
There is no better life. You're having your life right now, hanging out with your best friends.
Right here. It goes as far as this, and it goes as far as this. So we're right.
Well, all of us can say the same. So.
We can all say the same thing. Yeah. You think you're watching a show about space? We're just hanging out with our friends. Nicole, where do we find out more?
I have no idea anymore because my office is in the middle of a move. I'm somewhere. I still live at cosmoquest.org. It's where I do all my work. Come check out, again, the Earth or Not Earth app. My website's noisyastronomer.com. Hopefully I will also be blogging for Discovery News starting in 2014, because I'm pretty sure Ian O'Neill is really tired of carrying the entire
Bring us back!
we can't wait to write for you guys again. So, yeah, hopefully I'll be doing that again soon. But check out CosmoQuest. And hopefully next week I will be in my brand new office with my own office, and it'll be great.
Fantastic.
Yay.
Cool, and of course I am the publisher of Universe Today. You can find out more at universetoday.com. We've been releasing a mountain of videos on our YouTube channel, which you're watching right now. We had a great interview with Emily Lakdawalla this week about where we should search for life in the solar system, and she predicted the Europa thing, so it's great to see that. And next week we've got an interview with our good friend Dr. Thad Szabo, and then after that Ian O'Neill, and then after that Kevin Grazier. So it's great. We got a ton of really interesting interviews coming out. So all that stuff that we did down at YouTube, it's all going to be happening now. So thanks everyone for watching this week, and we will see you all next Friday. Goodbye.
Happy Geminids.
If we can. I don't know if people are going to be around for Christmas. I'm not sure. Anyway, we'll figure it out. See you guys later.
I'll be unpacking my office.
Some kind of delay going on here. They've totally changed Hangouts again, so welcome to the new style. Well, hey everyone. My name is Fraser Cain, and I'm the publisher of Universe Today, and this is your weekly Space Hangout. Yeah. For Friday, December 13th, 2003.
Dun, dun, dun.
So joining me this week, we've got the core crew, I think. We've got Amy Shira Teitel.
Hello.
From Canada. In Canada.
In Canada. Go team.
Welcome home.
Thank you.
Got David Dickinson in Florida, wishing he was in Canada. No, wait, it's the opposite.
Only warm spot in North America right now.
Oh. Jason Major.
In Rhode Island.
In Rhode Island, a sort of a horrible cross between Florida and Canada.
We're just northern Florida, really?
Right.
I'm so confused right now.
And confused Nicole Gugliucci.
It happens. Most of the time.
Most of the time. Cool. So we've got a bunch of stuff we're going to talk about today, I think. We're going to talk about the Geminid meteors, which is why...
It's pretty good. So you could expect to see 1 to 2 per hour, depending on how dark your sky is. One problem we have this year is the pesky moon. The moon is at waxing gibbous right now, and it's going toward full next week. So we only got a slice of very early morning where there's no moon and the sun hasn't risen yet, and there's no dawn twilight right now. So, and that's dwindling. So that's why I've been trying to get out the last few mornings. I've seen a few. I was looking on the International Meteor Observers Association's website. Their last real-time data came from 12:30 UT, which is 7:30 our time, Eastern time here today, and their zenith hourly rate was showing 63 per hour, but that was plus or minus 22, so that tells me that's a very low data set of observers. That's kind of a wide distribution right there. But this is an interesting shower to watch for, and this shower also is interesting in that it comes from the controversial rock comet 32 Phaethon, which is which has the behavior sometimes of an asteroid, sometimes of a comet. It's a comet that gets very close into the sun, closer in than Mercury on perihelion, so it's periodically, what they think is happening is it's getting material baked off it, like ice and things are sublimating off it. They also think this might actually be a dead nucleus to a comet that was...
David Dickinson looks so tired.
We're
going to talk about the forthcoming Chinese landing on the moon. Apparently a rocket, not an entire country or people. So we're going to talk about crazy jets on Europa. Just another reason why we're not allowed to land on Europa.
Jets! Europa, Europa, Europa!
Once a jet, always a jet.
That's a good one. That's a good one.
Reasons why a star might not be a star. And then Lakes on Titan. It's just a liquidy episode. An exoplanet with the biggest orbit and a interesting molecular cloud, M51. So let's start with the Geminids because we love meteors. So David,
Yes,
why are you so tired?
Because I was out looking for the last few mornings. I was out on vigil for the Geminid meteors, which is one of the most dependable meteor showers of the year. And currently, the Geminids have been getting more and more active every year, too. So it's currently one of the best annual showers, even better than the Perseids. But I think the Geminids, due to the fact they happen in December, which is the middle of Northern Hemisphere winter, kind of have a PR problem as compared to the Perseids. But the Geminids, their rate right now is approaching up toward zenithal hourly rate is in the past few years has been approaching over 120 per hour, which of fireballs as opposed to lower magnitude meteors. This one's it's about an even mix. This shower here, so I'll be trying to take images tomorrow, and I'll be out again if it's clear.
Well, I'll admit I'm a total fair weather meteor guy, especially so I love the Perseids. You know, the Leonids and the Geminids really kind of test my patience. I'll go out for a little while and look up, and then I'll get cold and go, I'll wait for summer.
Well, it's tough when you're imaging, too, because cold weather will kill batteries in a hurry. And if you're doing time exposures on cameras, that will also drain your batteries in a hurry. So
I just got a new camera, by the way.
Yeah.
I got
cool.
a 5D Mark II.
Oh, very cool.
Yeah, so I'm really excited. We're going to use it for shooting video, but I will also be using it for time lapses and things like that. So, yeah.
I usually carry an extra set of batteries in my pocket just to keep them warm. A lot of people will use external battery packs, or if you're near an AC source, you could have an AC power pack. That'd be another way to. But catching meteors is just a matter of shooting at a very wide exposure, a wide field of view, and it's something you can't really plan for. They can appear anywhere in the sky. They're going to radiate from the constellation Gemini. That's why they're called Geminids. But you just aim with the widest field of view you can and just do time exposures. With the moon, once active, got captured in the inner solar system. There's a lot of theories, and they didn't know the source of the Geminids until it was astronomer Fred Whipple in the mid-20th century that calculated, based on the orbit of 32 Phaethon, where the Geminids were probably coming from, what the source body was.
So when's the peak? What's the best?
The peak is coming at, I always think in universal time, so for Eastern observers, you'll just have to minus 5 hours right now that we're on standard time, is 2 o'clock in the morning universal time tomorrow, which favors the Atlantic because we're going to be turned forward. We won't be here on the U.S. East Coast, but on the other side of the Atlantic. It's going to favor UK, Europe, and then, but you know, the peak really, this shower is a very broad 24-hour peak. It's not like the quaternids that come next month, which are powerful, but some meteor showers only have a peak that lasts an hour or two. This one usually lasts over 24 hours. I was at a dark sky site in North Carolina, in western North Carolina last year, and I saw quite a few. The shower was one of the better displays of the Geminids or any meteor shower I had seen for some time.
Now, is this a fireball-y shower, Dave?
The average ratio between it's not exceptionally, not compared to the Perseids or any other. There are some showers like the Taurids that have a high ratio,